Hello everyone, welcome to Faculty Development Center, sponsored by MHRD and in association with RUSA SPD Maharashtra. At the foremost, I would like to thank Professor Devanand Shinde, Vice Chancellor of Shivaji University, and all the other authorities. Also, would like to extend thanks to Director of SPDP Maharashtra, Mrs. Meeta Rauji-Lochin. This is one of the best faculty development course which I have attended and which is very useful as a faculty to transfer and share knowledge to further aspirants. This faculty development program in data science is one of the best which I have attended so far. In this faculty development program, from the day one, we have learned different machine learning and data science technologies that can be used in today's era. From big data, Hadoop, Python, deep learning, and one of the components that I have learned is machine learning, especially focusing on neural network. And this session I am going to present on neural network. Let me introduce myself. I am Dr. Shruti from Chhatrapati Shahu Institute of Business Education and Research, Kolhapur. The contents that will be following my sessions are basics of what is neural network, what is a neuron, what are activation functions, and what are the different types of neural networks. So basically, a neural network is nothing but a simulation of human brain just to mimic what humans do, how humans think, and how humans learn. Same thing we are going to do, simulate our computers to do. Neural network is also a mathematical function that maps input to the output. The first neural network model that was presented by famous mathematicians McClellan and Pitts in 1943. So let's go into what is a neural network. So neural network is nothing but made up of neurons. Now neurons actually pass input values through functions and outputs the results. Neurons are then grouped into different layers. So we have the input layer, the hidden layer, and the output layer. And our input and output, we are going to have one layer. Our hidden layers can range from one to many. If it is a single layer, then single, one or two, we simply call it multi-layer. When our hidden layers extends beyond two, we go into deep learning. So neurons of each layer are then connected with links. And each link is associated with a weight that contains some information that we pass from one input signal of one neuron to another neuron of another layer. So basically, this is what the diagram shows about. We have the input layer, the output layer, and we can have one or more hidden layers. Let's go inside a neuron. So each neuron is going to maintain an internal state of its own, which is a function of inputs that are coming from different neurons, and this is then mapped into something called as an activation function. So what this activation function does is, it calculates the weighted sum of inputs, adds a bias to it, and then decides whether an output is to be fired to the further neurons or no. It all depends upon what type of activation functions we are using. So this is a biological, on the left side you can see a biological neuron where we have a nucleus, that is a cell body, and all other neurons are connected to dendrites. Similarly, we are mimicking a mathematical neuron model which is nothing but a cell body which does the summation of weights with inputs, and depending upon the summation, if it goes beyond a threshold value, the neuron is going to fire an output, else it won't. So we have different activation functions. It is, first of all, a bipolar binary and unipolar binary, which are called as hard limiting activation functions, basically used in discrete neuron model. And we have unipolar continuous and bipolar continuous, which are called as soft limiting activation functions, which we call as sigmoidal characteristics. In activation functions, we have a simple activation function which is called as an identity function, which simply maps input to output for all x. Then we have a binary step-up activation functions. Depending upon whether our value is greater than 0, it will give 1. If it is less than, then it will give 0, based upon whether our summation of weight is greater than the threshold. This threshold is nothing but we define it as theta. Then we have a bipolar step-up function which ranges from -1 to 1. We have sigmoidal functions. Basically, the most popular activation function that we use is sigmoidal functions, and it is a continuous function. Okay. We have a ramp function which ranges from 0 to 1 depending again on the threshold value. Let's go next to neural network types. These neural network types can be classified into different models based on their internet connectivity, that is interconnections, the learning method, and the activation functions. So neural networks are classified not only on the learning methods, but it is also classified based on how it is the neurons are interconnected, what is the learning method that is being used, as well as what is the activation function that we use. So let's go first, classification based on interconnections of neurons. So we can broadly classify it into feed-forward neural network and feedback neural network, or we also sometimes call it as recurrent neural network. A feed-forward neural network is one of the most simplest form of artificial neural network, where inputs will be forwarded to the further layer and our information flows in only one direction, that is a forward direction. Okay, so there are no cycles, no feedback loops, and this neural network may or may not have hidden layers. If it doesn't have a hidden layer, then it is called as a single feed-forward network. If it has a hidden layer, then we call it as multi-feed-forward network. Next is the feedback neural network. So when we say feedback, that means after output, whatever is our desired, we can again transform or feed the input back to the previous layer neurons, or also the neurons of the same layer. So it is not that we only have to give feedback to the previous layer neurons, it can also give feedback to the neurons of the same layer. So feedback networks can have signals traveling in both the directions, not only forward but also in backward direction. So when the outputs are directed back as inputs to the same or the preceding layer neuron, this results in the formation of a feedback network. Feedback networks are very powerful, and at the same time it can at times be very complicated. Okay, so feedback networks are very dynamic. Their states keeps on changing until we reach an equilibrium state where our model is fully trained. So these are again different types of feedback neural network. We have a single node feedback neural network. We could have a single layer recurrent network, or we could also have a multi-layer recurrent network. The next classification feature is the learning method. So basically the process of modifying the weights that we have put on the connection links of the neural network with the whole objective of achieving an expected output is called training of a network. So this process by which a neural network performs learning from data to adjust the parameters and as well as structure is a part of training of neural network. And we can use different learning methods, that is supervised learning method, unsupervised learning method, and reinforcement learning methods. For now, we can further learn the different learning methods. It's again a big topic to be talked about, the different learning methods. Thank you very much.